This is the second part of our introduction to arrays in Numpy. Make sure to watch the first video before this, unless you already know something about Numpy. So what we just worked on was how to create an array and how to access and index different parts of an array in Numpy. So here we have an example where we combine some operations. And we're thinking a little bit about what data might look like in the business world. And it's useful to think about spreadsheets as an extension of what we're doing here, where each column in a spreadsheet is a variable that we might want to measure something about. So with that in mind, here's an example of how we could find some summary statistics for the first column in an array that we've made. So let's take a look at the array AY. AY is the array of integers, just 1 through 18. Nothing very special about that. But if we wanted to get the first column, that would just be this colon, which says take every row from column at index 0. And then what we're going to do is for that column 1, we're going to find the sum, the mean, and the standard deviation, and then the separate /n is just how we're customizing our outputs. So let's take a look at that. All right, there we go. So that just took the first column, which is just 1, 7, 13. So I'm not going to verify that these are correct. I'm pretty confident that they are. Here they are. Yeah, these are the correct numbers. Okay, there's something called the transpose of a matrix or an array. So we can talk about matrices. A matrix is a two-dimensional array, whereas array is sort of more of a general term for any kind of data that's arranged in multiple columns. So let's see what a transpose looks like. We know what, and let's also print the matrix AY and the transpose of that matrix. Okay, so here they are. You can ignore the stuff below. So all the transpose does is it flips the matrix on its side so that the rows become columns and the columns become the rows. There's another way to do this. We could also, in Python, there are so many ways to do the same thing. And you're going to see both of these. So the transpose, we should now have two of the same. No, not helpful. Maybe that's a function. Yeah, that's what it is. Okay, so I guess two ways to get the transpose of a matrix. You'll see both. All right, so here what we have is an iteration over the columns in the transpose of the array. And that's just because it's much easier for, it's much easier to iterate over rows. So instead of accessing each column, which is harder, we access the rows of the transpose of the matrix, which correspond to the columns of the original matrix. So you have to trust me on that's an easier way to iterate over the columns of a matrix. Just flip it on its side. And then we can go ahead and find the column sum, the column mean, and the column standard deviation. So we should now get six lines of output here for the sum, the mean, and the standard deviation. The standard deviation is the same for all of them. That's what we would expect because they're all 1 unit apart. So something to keep in mind, I brought that up here because I've seen that as a common problem on Stack Overflow. People wanted to iterate over the columns of a matrix, and the best response was to use the transpose and iterate over the rows of the transpose. So that's just a little heads up about that. Next, we have two more topics. One is slicing, which can be read in a pretty straightforward way. We just have to remember how the indices go, and that the indices start at 0. So if I were to say I want columns 3 through 5 from rows 3 through 5, I would slice out and keep everything within the indices of 2 to 4 in the first set of rows, and then the columns to add indices 2 through 4. So let's see what these things look like. The best way to learn this stuff is to just keep running things and seeing the output. So we're slicing a piece. We're slicing pieces of the array. Let's go back to the array to make sure we understand what's happening. Okay, so what did I get? 15, 16, 15 and 16. Okay, so from rows, oh, there is no row 4. That's silly. Right, so from row 2 to 3, there's only, that only includes one row. So the index 2, there's no row 3 either. So at index 2, take columns 2 through 4. So I get the 15 and the 16. Why didn't I get, oh, I see I didn't get 17 because the end point is excluded. So we're taking 2, 3, and not 4. All right. So that was sort of silly of me. This should actually say, maybe I'll make it into something like 1 to 3, and that could give us something more informative. Yeah, okay. So I take rows at index 1 and the row at index 2, and then I think you get the idea now. Okay, so the next one is columns 1 through 5, this should say, from rows 2 through 3. Yeah, my example needed to exclude the the end point of the slice that I'm choosing. So that's a little bit better. I'll just fix that a little bit later. I'm gonna make those things match up. Okay, so hopefully you get the idea of slicing and how it's used, and that could be a useful tool if you're trying to pull out a specific piece of data from a data frame that we'll see later in pandas. Okay, the last topic for this video is something called reshaping. So there's an attribute in the Numpy library called shape, where we can find out the dimensions of a matrix. And so we just say print for the AY matrix, print the shape, and it's going to give us a 3 and a 6. So we'll see that in the first part of the output. When we run this, we get 3 and 6. The next line here is it's a function called prod for product. So I can input as an argument the shape of the array, the dimensions of the array, and what this does is it multiplies my rows times the number of rows times the number of columns. So in this case, we can obviously just do this in our head, but what if we have a really large data frame and we want to know how many entries are in it? We could use this product function, and that gives us 18. And then we need that information so that we can do something called reshaping. That's another function which allows us to specify some new dimensions, a new number of rows, and I'm choosing 9, and then a new number of columns, and I'm choosing 10. So I have to make sure that the product of those two numbers is equal to the size, equal to the size of the array. So that is combining some operations for a column, and then for all columns, slicing, which I need to fix a little bit, and then reshaping. Some useful skills to have when working with arrays in Numpy.